Hi all YouTube, AC Dodd here again, and I just wanted to take the opportunity at the end of the tuning season to go through and discuss with you all how an SU carb works. Now the reason why I'm doing this is because I've seen a lot of cars and nothing changes. People do not understand how this thing works, moreover how it's calibrated, etc. So what I'm going to do now is just take the opportunity, perhaps even in a couple of parts, to kind of go through the carburettor, show you how it works and what some of the calibrations are. This is not going to be about how to calibrate it. This is going to be about how it works, so that you can understand some of the things that I do when I'm out on the road tuning, and it'll obviously help you in your own abilities to live with the SU carburettor on whatever car that you're using it on. So what I'm going to say here is not just related to classic minis. It can be used across all engines and all cars, obviously as long as the carburettor is sized correctly and obviously calibrated correctly. So anyway, without further ado, let's get stuck into the video. So as an example for this video, I've got one of my rebuilt HS4 SU carburetors. Now this particular one is nothing special, but it is one of my fast road units. But for the purposes of this video, it is basically an example of which we're going to use to explain how in this episode the basics operation of the SU carburettor. So in terms of the actual particular type of carb, as I said, this is an HS4, but it's the wax jet version, and it's also a bias sprung needle. So this is not a fixed needle carb, which we'll discuss more of later. But for the purposes of this is an excellent product to be able to talk through how these work. So I'm sure you're all aware of the basic principles, operation principles of a carburettor. Now in this particular case, all we're looking at really here is engines this side. So engine pulls here, you open the valve, it can pull air through the carburettor. The carburettor's job is to mix that air with the appropriate amount of fuel, and then obviously that fuel and air mix goes into the engine and it's combusted. You know, that's in essence the very basics of it. But this is where it gets a little bit more complicated, because people think SUs are simple, and they are very mechanically simple, but in terms of operation, they can get confusing because people try and oversimplify what's going on, and if anything, it's anything but simple what's actually going on when the carb is working. So let's see if we can attempt to demystify that. Okay, so let's start off with identifying the major parts of the carburettor. So, you know, we'll do this in big handfuls so it's nice and straightforward. But what we're basically talking about here, this is the float bowl, and its job is to take the delivery of fuel from the fuel pump, which comes from the tank, into the float bowl to hold a reservoir of fuel that the carburettor can draw on to be able to mix it with the incoming air. So the main aspects of the float bowl are there's an outlet via the jet, which is this is the jet on the bottom. So fuel flows from the float bowl up to the jet and up into the carburettor body, and then on the top there is a mechanism. So what I'm going to do now is we'll take that off, and then we can investigate what's inside so you can actually see the mechanism inside and how it works. So start by removing the screws to the float bowl. Okay, so remove the screws, and then we lift the float bowl lid off. Inside we can see there is the bowl. Obviously there's nothing in there at the moment because this is a new carburettor. Put that down there, and then we can look at the float bowl lid assembly, gasket, and then we have clearly the float and this is a stay up float from SU, so it's a genuine new replacement float. And under the float there is a needle and seat assembly. So what we have here is effectively a small hole with a tapered seat in it, and that is known as the needle. That goes inside, and when pressure is applied from the float, that pushes that tapered end into that seat, and that forms a seal and stops the fuel coming into the float bowl. And when the float bowl fills up, the float assembly lifts up on the fuel, and you can see in there that the arm on the float is actually raising the needle. And when it gets to a certain point, the needle makes contact with the seat and it shuts off the flow of fuel. This is exactly like your toilet cistern at home with a float assembly. When the water gets too high, the float comes up and shuts off the fuel. Very, very basic, okay? These carburetors have always had a very basic system, but again, it's one part of the operation of the carb that's often misunderstood, because there's a couple of things that are important. One is the pressure of the supplied fuel. So you only want 1.5 to 2 pounds per square inch at the inlet, okay? And I'm pointing at that one because that one is the inlet, and on this carburetor lid, that one is the overflow. And what the overflow is if you have a problem in here with any dirt, and this, when the float gets up for some reason, doesn't shut off the supply of fuel, what will happen is the float bowl will overfill, and then it will flood, and it will flood the carburetor, and it will flood the engine as well, and doesn't end well for the piston rings if it's left. So what happens here is any excess fuel gets pushed out of here rather than being forced into the jet of the carburetor and making the engine running very, very rich, which is dangerous. Older carburetors have different float lids. This is a later one with an overflow. Older carbs just have the one nozzle, and then under that nozzle they'll have a vent hole, and when fuel comes out of there, it's the same thing, it's just flooding. But the later carbs, instead of letting the fuel run out over the lid all the way down the body and maybe over a hot exhaust manifold, what this does is allows you to fit a pipe so that they can be taken safely away and run down the side of the clutch housing, which is what is used on a classic Mini, for example. One of the other things that's important is the correct float height setting. So when you use an original float on these later carburetors, they are this type, okay? And they sometimes fail with the modern fuel, so it's not always guaranteed that you can reuse these. So I've definitely had a few of these go wrong. So the best thing to do with these when you get a carburetor and you're rebuilding it is to replace it for this modern equivalent that's made to work with the modern ethanol based fuel, and obviously they are made from a stay up design, so they won't ever flood. So the next thing you want to be able to do is set the float height. Now on this I use 4mm as a float height, and I set all the HS carburetors to that height. When you have this type, the height is not adjustable. So the reason why this carburetor had a new float is because when I put this one together, the float height was much too high. And what I mean by that is this high is when this is nearly touching there, okay? Because we have to remember, in operation it's this way up. So when the float comes up and it's filled, it goes high. If it carries on and it can go right the way up, the fuel level in the carburetor is too high, and that also that basically produces a situation where there's too much fuel in the jet in the carburetor, and it can start running rich. So again, float height is important and it needs to be set. Okay, so I've put the float lid back on. So the next thing that we're going to have a look at was, we already talked about the jet, but the jet assembly is effectively where the fuel is metered from. But unlike, say, like a Weber carb where you have a calibrated jet orifice and you can change the jet sizes for different scenarios, the SU works differently, and it uses a needle in a fixed orifice jet. So in this case, with the HS2, it's a 90 thou jet in this application. So the needle goes in there, and the needle is raised and lowered in the jet to be able to change the surface area of fuel which is presented to the airstream. So the other thing that the jet does is via this mechanism. This is the cold start or the choke. So when you move that, and this is connected to the choke control in the car, that effectively pulls the jet down, and what that does is that moves the jet position from a fatter part of the needle to a much thinner part of the needle, which effectively massively richens the fuel mix, which then gives you the appropriate fuel enrichment to allow cold starting. On the side of the carburettor, there is also this lever, which is effectively the throttle lever. So, and this is connected to the throttle spindle, so that when you open the throttle, or in the case of a car, when you push your foot on the accelerator, that valve is opened, and that's what communicates vacuum from the engine to the carburettor and starts to draw air through the carburettor. But you'll also see that inside the carburettor it's blocked, because there is a piston, which I'm now moving up and down with my finger. So the next thing we're going to have a look at is the piston. So we'll just take that out, and then we can withdraw the piston and needle assembly. So I'll put that down to one side for the minute, and we'll come back to that in a second. Now, looking at the carb body, we can see inside, we talked about the jet and the choke. So you watch that as I move the choke, you see the jet, it moves down. And that is, as I said, the mechanism by which fuel enrichment happens for cold starting. And we can now look through the carb from the rear, open the throttle, and you can see the butterfly opening, and you can see that's the path for air through the carburettor when the piston is not fitted. So why does this carburettor have a blocking piston, and what's that all about? Well, let's have a look. So this is known as the bell chamber. This is the piston. There's a spring inside, and there's a damper inside the assembly. More on that later. But this assembly is responsible for the metering of the fuel. So let's explain how that works. Okay, let's have a look at the dashpot assembly. So, as we said before, it consists of the bell chamber, the piston and the spring and the damper. There's also the metering needle. So, the most important thing to understand here is this is what measures airflow, okay? And the way it does that is when you open the throttle, you have two ports here, okay? And they are connected to the inside, okay? And what that basically means is those two ports are connected to the inside area here, okay? And what stops air passing between the inside and the outside to here is a very nicely machined fit between there and the inside diameter of here, okay? So effectively, once that's inside there and that's inside the carburettor, what happens is, as you open the throttle, two things happen. Firstly, vacuum from the engine is communicated to these ports, which then evacuates that chamber up the top, and that causes the piston to rise. Then you get an inrush of air underneath the piston. Now secondly, the inrush of air underneath the piston causes a Venturi effect over these holes as that goes across. So it effectively draws further air out of the inside of there, causing the piston to rise further. Okay, so depending on how far the throttle is, how big the engine is, how far the throttle is open, how big the engine is, the speed of the engine, and also the tension of the spring and the oil in the damper, depends on how that rises and how fast it rises. The important thing to understand here is this is effectively what measures your airflow, and as that rises, the needle is pulled from the jet. And the way this arrangement is set up is it gives you what they call a constant depression, okay? But it's a bit more complicated than that, because we have constant depression and then we have some modifiers. So we have modifier in the form of the damper. So when you snap the throttle open, instead of that opening quickly, that has to act against the damper, which slows the rise down. Now, if you open the throttle fully, this piston will want to rise quickly, but that is retarded by the damper. And what therefore happens is, as that retards the speed of the piston opening, it causes a local increase in the depression over the jet, which pulls more fuel off for a given needle position. So the damper effectively richens the needle at any given dynamic movement. So as you move the throttle, it will enrichen, okay? So there's a couple of things going on. One is the mixture given by the needle at any steady state is determined by the taper on the needle. And then as you open the throttle, it will go lean if there was no damping effect. So the damping effect is there to give us a momentary increase in fueling as you open the throttle. So that's how the accelerator pump effect works. Now, at any steady state cruise, what I mean by that is light throttle and the RPM is not rising, the throttle is not moving, so everything's fixed and the engine's cruising. The piston rises dependent on the air coming underneath and the vacuum signal, and also the speed and the size of the engine and the tension on that spring. So as you can imagine, when we get into calibration further down the line, there's a lot of things going on here that perhaps you didn't first realize, and that's why a lot of people get confused with actually what's going on. So the important thing to understand is the relationship between airflow and the position of the piston is all adjustable. And that's what carb calibration is. So we'll put that back in the carburettor and then we'll carry on going through the rest of the carb. So, got the top back on. Let's carry on moving around the rest of the carburettor. We've got a few other things to look at, namely adjustments and vacuum. So, adjustments. That screw there is responsible for idle. So as you turn that, you'll see the lever moving. So that is bench set when I build a carburettor, but clearly it's set on the engine when the engine's running. It's not a screw that needs lots of work. In practice, once you set it, that'll be pretty much it for the time being on the engine where it runs. Wear and seasonal changes in temperature, etc., may require small adjustments on that, but in reality, on a good carburettor like this one that's nice and sealed, once you set the idle, it should pretty much stay there for quite some time before wear starts to affect it. We've already mentioned the choke, but the most important thing to understand is the mixture nut. Now this is the mixture nut. Now many people use the mixture nut to adjust obviously the way the engine runs and the way the engine performs. The most important thing to understand about the mixture nut is it's only used to set the idle mix, okay? Using this nut to try and adjust the way the engine drives, as I've said in previous videos, is the fastest way to wash out the rings in your engine. So you only use this mixture nut to set the idle mixture. And if that means that you've got to have a lean mixture to pass emissions, then that's what you use that for. If the engine doesn't drive right after that, that's because you need to look at the calibration of the rest of the carburettor. So the other thing we're going to quickly touch on is the vacuum and the vacuum takeoff for the distributor. So on my carburettors, I use what's called ported vacuum. Okay, so ported vacuum is completely different to manifold vacuum. So what I'll do is I'll get a different carburetor so I can show you the difference. So forgive the disgusting state of the carburetor that I'm showing you now, but this is the sort of carburetors that people send in for rebuilding. This is in very poor condition, but the reason why I'm using it is because it has manifold vacuum. So what I'm going to do is I'm just going to zoom that in so we can see what's going on. All right, that hole there, indicated by my screwdriver, is the hole for the vacuum nipple. Okay, now what that basically means is when the engine's running, manifold vacuum is here. Okay, so full engine vacuum is on that port all the time the engine's idling. So that's when it's the throttle valve's closed and the engine's idling. As you can see, that port is open to manifold vacuum. So that means full engine vacuum is communicated to that port, which means full engine vacuum, if it's connected to a distributor, is communicated to the vacuum advance unit, which means that the distributor is advancing the ignition timing, and usually anywhere between 25 and maybe 35 degrees of ignition advance idle. If you're trying to pass emissions, this is definitely something that you don't want. So in contrast, if we look at the fast road carburettor, which I make, you'll see that there is no port, except when you just move the throttle, you'll see it uncovered there in the center of the screen. So the idea is when it's idling, there's no vacuum on that port. As soon as you touch the throttle, that port is uncovered and vacuum is communicated to that port. Clearly, when you open the throttle, vacuum drops anyway. But just for that transition, and that's enough for cruise, that gives you a vacuum signal which is used to advance the ignition timing at part throttle. And again, when you come back to idle, the port is closed off. So that's the difference between ported and manifold vacuum. Now, one last thing I want to cover just on this first episode is looking at the jets. So there are a couple of different types of jet you can have, but this is basically the wax jet. Now, all my carburetors feature a wax jet or a means of temperature compensation. So what that basically does is, depending on how warm the fuel is, it will move the jet automatically in relation to the base setting that you set with the screw, and therefore it's used to ensure that the engine stays running lean as it warms up. Okay, so I use that on all my carburetors. Now, these have been much maligned over the years, and people even changed them to the fixed jet type. If If you change them to the fixed jet type, you won't get no compensation as the engine warms up. And I've certainly found that as the engine warms up, you can end up running richer than you would normally want to do. So I always fit these to my carburetors. The HIF carb uses a bimetallic strip arrangement, whereas the HS uses this wax jet. Lastly, I just want to say this part here is the pipe used to take your crankcase gases and draw them into the engine to be burnt. I'm not a fan of using open crankcase vents on a road engine, so the good thing about using that port to take away any nasty gases so you don't breathe them in is it also puts a vacuum on the sump and the crankcase, which effectively draws out gases, but also makes all your seals operate under a vacuum, so they actually seal better, as does your piston rings, believe it or not. So running this on a road engine is an absolute must. Okay, that's it for this part. If you like this video, please don't forget to give me a like, please subscribe, and also share. As ever, I'll see you soon with part 2.